नमस्कार विद्यार्थी मित्रांनो. आज आपण शिकणार आहोत चॅप्टर नंबर 4, डबल अँड ट्रिपल इंटिग्रल्स. दिस इज द लास्ट चॅप्टर ऑफ फर्स्ट कोर्स, calculus of several variable. Now we start the definition of double integral. Let f of xy be defined for all points in a finite region R and xy of the xy plane. Delta x delta y be the elementary area of the region R surrounding by point xy. Then the limit delta x tends to 0, delta y tends to 0, summation of f of xy delta x delta y, and it is written as double integral over the region R f of xy dx dy, and it is called as double integral of f of xy over the region R. Now this is the definition of double integral. Instead of this definition, you can solve the example in the very simple manner. This is the first example. Solve or evaluate integration from 0 to 1. Again integration from 0 to 1 dx dy. Now here f of xy is not given. So consider f of xy is equal to 1. If you consider f of xy is equal to 1, then what is the integral of 1? 1 dx. So consider integration from 0 to 1, integration from 0 to 1 dx dy. So integration of 1 is x. So integration from of this integration from 0 to 1 dx is nothing but integration of this between limit is nothing but x, and this limit varies from 0 to 1. Lower limit is 0, upper limit is 1. So x varies from 0 to 1. So put up the first limit as 1 and minus second limit 0. So 1 minus 0. So we get single integral. Integration varies from 0 to 1. 1 minus 0 is 1 dy. That's the integration from 0 to 1 dy. Now again take the limit and take the integration with respect to y. So what is the integration of y? Integration of 1 with respect to y. Integration of 1 with respect to y is y, and limit varies from 0 to 1. Lower limit is 0, upper limit is 1. So again put the first limit 1 minus 0, that is 1. This is the first example. Now second example, uh, evaluate integration from 0 to 2, integration from 0 to 1 xy dx dy. Now here the solution, integration from 1 to 2, integration from 0 to 1 xy dx dy is equal to, so first we can take the integration with respect to x. So first take the solve this between between integration from 0 to 1 xy dx. So what is the integration of xy with respect to x? X integration काय मिळेल x square by 2. Y is a constant here. So integration of x is x square by 2. Y is constant. So we get integration as x square y upon 2, and take the limit varies from 0 to 1. First limit 0, upper limit 1, and here we have taken the limit with respect to x. So limit also varies from 0 to 1. So x varies from 0 to 1. So put the first per value of the x. So x is equal to 1 जर आपण टाकलं first, तर काय मिळेल? 1 square is nothing but 1. So y by 2. So here we can take 1/2 as a common outside of the integration. So just here we have to take the integration for x square y. So if we put x is equal to 1, then we get y into 1 square, and y into, put x is equal to 0, then 0. So y into 1 square is y. So 1/2 integration from 1 to 2 y dy. Now we have to take the integration with respect to y. So integration of y is nothing but y square by 2. Again we can take this 1/2 and this 1/2, 1 by 4 as a common. Just take the uh, put the values of limits varies from y varies from 1 to 2. First put the upper limit as y is equal to 2. Y is equal to 2, then we get 2 square minus lower limit y is equal to 1, so 1 square. So 2 square is 4 minus 1, that is 4 minus 1 upon 4, that is a 4 upon 4, that, sorry, 4 minus 1, 3 upon 4, that is 3 by 4. This is the second example. Now third example, evaluate integration from 0 to 4, evaluate integration from 0 to root y x y dx dy. Now here the limit contains the variable. So if limit contains variable, so we cannot take as order given in dx dy. So we cannot take the first as a integration with respect to x or integration. We have to choose the what is the first integral. So here, so in this limits, sorry, in this integration, first integration varies from 0 to root y, and second integration varies from 0 to 4. Since here limit contains y, so the first integration must be varies from x, x varies from 0 to x root y. So first integration must be with respect to x. So in between limit we have to take the integration with respect to x first. So the this limit becomes integration y varies from sorry, integration y varies from 0 to 4, integration x varies from 0 to root y x y dx dy. So first we have to take the integration with respect to x. So integration with respect to x, and what is the integration with respect to x? Xy is integration capital, x the integration x square by 2, y as a common. So we can take put the first value of y, x is equal to y, sorry, x is equal to root y. So if you put x is equal to root y, so y into, put here just x is replaced by root y. So y into root y square upon 2. Then put the second limit minus of y into 0 upon 2. So it becomes y into root y is a square y. So y into y square minus 0. So 1 half, we can take 1 half as a common. Integration 0 varies from 0 to 4 y square dy. So 1 half, we get y cube by 3. Again we have to take integration of y square. Y square is integration y cube by 3, and limit varies from 0 to 4. So put the first limit y 4 cube, and then minus second limit 0 cube, that is nothing but 0. So 4 cube is 64 upon 6. So we get 64 upon 6, that is nothing but, we can you can take the uh, now next example, integration varies from 0 to 1, integration varies from 0 to 1 x square minus y square dx dy. So this integral becomes, first we have to take the integration with respect to x. So what we get, integration of x square is nothing but x cube by 3, integration of y square, and now we have to take the integration with respect to x. So y square is a constant, integration of constant is y square into x. So integration varies from 0 to 1. So put the first limit as x is equal to 1 in this. So if you put x is equal to 1, then 1 cube by 3, that is 1 by 3. And if you put here x is equal to 1, then we get y minus y square. Now we put second limit as x is equal to 0. If you put x is equal to 0, this term is 0. If you put x is equal to 0, this term is 0. So just minus 0 into dy. So we get integration 0 to 1, 1 by 3 minus y square dy. Now we have to solve this integration with respect to y. So what is the integration of 1 by 3? 1 by 3 is a constant. So integration is in 1 by 3 into y, you know, minus integration of y square. Y square is integration y cube by 3. Again limit as 0 to 1. So put first limit y is equal to 1. So if you put y is equal to 1, then we get 1 by 3. If you put y is equal to 1, again we get 1 by 3. So 1 by 3 minus 1 by 3, we get 0. Next example, integration varies from 0 to 2. Integration varies from 0 to 1, x square y square dx dy. First, we have to take the integration with respect to x. We get x cube by 3 plus xy square. Limit varies from 0 to 1. Put first limit as x is equal to 1. So 1 by 3. X is equal to 1. So y square dy. Second limit, if you put second limit, then we get minus 0. Okay. Then we have to take the limit as a sorry, we have to take the integration with respect to y. So what is the integration of 1 by 3? That is y by 3. Integration of y square is y cube by 3. Limit varies from 0 to sorry 1 to 2. So put first limit as 2 by 3 and 2 cube by 3 minus second limit 1 by 3 and plus 1 by 3. Now this is 2 by 3 plus 8 by 3 minus 2 by 3, that is nothing but 8 by 3. This is example 6. Evaluate integration varies from 0 to 1. Integration varies from 0 to x square e raised to uh, y by x dy dx. So here limit varies from 0 to x square. So we have to take first solve the limit with respect to y, because limit contains the terms of x. So first limit with respect to, we have to take the first integration with respect to y. So integration varies from 0 to 1. Integration varies from 0 to x square e raised to y by x dy dx. So integrate. So we have to take the first integration of e raised to y by x. So what is the integration of e raised to y by x? Integration of e raised to y by x is e raised to y by x divided by derivative of y by x with respect to y. That is nothing but 1 by x. So put first value y is equal to x square. So we get y is equal to, if we put y is equal to x square, then e raised to y square, sorry, e raised to x square by x. So e raised to x square by x, आणि हा डिनॉमिनेटरचा डिनॉमिनेटर पुन्हा आपला न्यूमरेटर होईल. सो x into e raised to x square by x. Again put y is equal to 0. So if we put y is equal to 0, then we get e raised to 0 x into e raised to 0. So x into e raised to x minus this final integration. Now we have to take the integration with respect to 0 to 1, x into e raised to x minus x dx. So now we have to take the integration with respect to x of this x e raised to x. What is the integration? You have to take the integration by parts. So we get x into integration of e raised to x minus 1 dx minus integration of derivative of x into integration of e raised to x minus 1 dx. Limit varies from 0 to 1. That is, this integration is nothing but e raised to x, the integration e raised to x, and once the integration 1 sorry once the integration x. So x into in the bracket e raised to x minus x minus integration of derivative of x is 1, and integration of e raised to x minus 1 is e raised to x minus x dx. Again we have to take the integration of this. Again integration of this is nothing but e raised to x into x square by 2. Now this is the final limit. Just put the values of limit. First value as 1 and second value as 0. जिथं जिथं x असेल तिथे 1 टाका, नंतर मायनस जिथं जिथं x असेल तिथं 0 टाका. That is if you put x is equal to 1, then we get x into e raised to 1, that is e x 1 square, that is 1, e raised to 1 is the e, there's a 1 by 2 minus this is 0, this is 0, e raised to 0 is 1, and this is 0. So we get e minus e cancel. So minus 1 half, sorry, minus 1 plus 1 half, and minus minus plus 1, that is nothing but 1 half. Minus 1 plus 1 gets cancelled, we get the final answer 1 half. Next example, integration varies from 0 to 2. Integration varies from 0 to x dx dy upon x square plus y square. Now we have to we can solve the integration with respect to y first, because this limit contains the value of x. So what is the limit with respect to sorry integration with respect to y? So we have to take the integration with respect to y first. So integration of 1 upon x square plus y square. The this the value formula for this integration of 1 upon x square plus y square dy is nothing but 1 upon x tan inverse y upon x. Integration varies from 0 to x dx. So put first value as x, y is equal to x. So x upon x is 1. So 1 upon x tan inverse 1 minus 1 upon x tan inverse 0. So tan inverse 1 is pi by 4, and this is 0. So integration varies from 0 to 2, 1 upon x pi by 4 dx. Pi by 4 is a constant, we can take out outside. Integration varies from 0 to 2, 1 upon x dx. 1 upon x, the integration log x. Put the limit varies from 1 to 2. पहले लिमिट टाका 2, that is log 2 minus log 1. Log 1 is 0, so log pi by 4 log 2. This is the answer. Now, example 8, evaluate integration varies from 0 to 1. Integration varies from 0 to root of 1 minus x square dx dy. 1 upon 1 plus x square plus y square. Now, this limit contains the value of x. So, first we have to solve the integration with respect to y first. So, here we take the integration with respect to y first. So, what is the integration of this? This is the we have to take the integration of y, so this is the constant under root of 1 plus x square bracket square. So this is of the type 1 upon a square plus y square. 1 upon a square plus y square, integration of 1 upon a square plus y square is nothing but this is the formula. 1 upon a tan inverse y upon under root of 1 plus x square. Now we have to take the integration varies from 0 to root of 1 plus x square. So 0 to 1, 1 upon under root of 1 plus x square tan inverse 1 under root of 1 plus x square upon under root of 1 plus x square minus 1 upon under root of 1 plus x square tan inverse 0. Now this is a 1 under root of 1 plus x square under root of 1 plus x square is nothing but 1. So 1 upon under of 1 plus x square tan inverse 1 into tan inverse 0 is 0. So tan inverse 1 is nothing but pi by 4. It's the 1 upon under root of 1 plus s square into pi by 4. So pi by 4 we can take out outside. Integration varies from 0 to 1, 1 upon 1 under root of 1 plus x square dx. Now here again we can use the formula for what is the 1 upon under root of 1 plus x square. That's the log of x plus under root of 1 plus x square. Limit varies from 0 to 1. This is a direct formula. So first we have to take the x is equal to 1. So log of 1 under root of 1 plus 1. And we now we can take the second limit log of 0 plus under root of 1 plus 0. That is the log 1. Log of 1 plus root 2 minus log 1. That is the pi by 4 log of 1 plus root 2. That's the answer. Now, next example, integration varies from 0 to 1. Integration varies from 0 to 1 minus y in the bracket y minus root x dx dy. Now, here we have to take the integration with respect to x first. So, integration with respect to x. What is the integration with respect to x? Y is a constant. Integration of uh, y is nothing but yx. Y is a constant. So, integration of with respect to x is yx. Integration of root x is nothing but root 3 by 2. रूट x ला आपण कसं लिहू शकतो x रेस टू 1 हाफ आणि x रेस टू n चं इंटिग्रेशन असतं x रेस टू n प्लस 1 अपॉन n प्लस 1. सो 1 हाफ प्लस 1 upon 1 half plus 1, that is x raised to 3 by 2 upon 3 by 2, and limit varies from 0 to 1 minus y. So put the first limit 1 minus y, x is equal to 1 minus y टाकलं तर y into 1 minus y. नंतर x इज इक्वल टू 1 मायनस वाय टाकलं तर हा 3/2 वरती जाणार 2/3 होईल आणि 1 मायनस वाय रेस टू 3/2 डीवाय. आता पुन्हा याचं आपल्याला इंटिग्रेशन घ्यायचं आहे. याला आपण सेपरेट करून घेतलं y मायनस वाय स्क्वेअर मायनस 2/3 1 मायनस वाय रेस टू 3/2 डीवाय. The integration of y is y square by 2, integration of y square is y cube by 3, 2/3, integration of this is nothing but 3/2 plus 1 upon 3/2 plus 1 into derivative of 1 minus y, that is minus 1. So we get 1. Now we have to take the first limit as y is equal to 1. Y is equal to 1 टाकलं तर 1 half 1/3 and 2/3 into y is equal to 1 टाकलं तर 0 होईल हा. नंतर y is equal to 0 टाकलं तर काय मिळेल, हा 0 होईल, हा 0 होईल, फक्त हा इव्हॅल्यूएट 4/15 into 1. So 1 half minus 1/3 minus 1 4/15. Take the LCM of 3, 2, 3 and 15, that is number 30. आणि करस्पॉन्डिंग व्हॅल्यूज ने न्यूमरेटरला मल्टिप्लाय करा, दॅट इज 15 minus 10 minus 8, that is minus 3/30, that is minus 1/10. This is the answer. Now in the next lecture we have to solve the integration by change of variables.